In this session, we will discuss about the importance of fiscal policy in stabilizing economic activity. And when I use the word stabilization, please note that it doesn't necessarily mean that we always are trying to increase the growth rate or increase output. Sometimes it may also refer to moderating the growth rate if the economy is overheating. If we trace back the origin of the use of fiscal policy to stabilize economic activity, it can be traced back to the time period of the Great Depression. Now, in the late 20s, when the US economy was faced with the Great Depression between 1929 and 1933, we find that output fell significantly, prices also fell, and unemployment rose quite markedly. Now, at that time, the prevalent thought was that the market has its own self-correcting mechanism, and when the US government, the US president at that time, he was looking for some help from economists how to improve the situation. The recommendation he received was that don't do anything. The economy has its own self-correcting mechanism and allow time for the economy to improve on its own. Now, the government waited, but things instead of improving rather deteriorated more and more. Now, around that time, we find the birth of a new school of thought, which is the Keynesian school of thought, and the importance of fiscal policy was brought into the economics literature by J.M. Keynes. And what he suggested at that time to improve the economic scenario was using government policy to invigorate spending in the economy, and why spending matters and why government need to play a more active role in the economy when the chips are down. That we can appreciate if we see the concept of equilibrium income. Now, I have already discussed with you how equilibrium income in an economy is obtained. Now, if we plot income on the on the if I plot income on the x-axis and different components of planned expenditure on the y-axis, you would notice that we had drawn a 45-degree line, and each point on the 45-degree line represented a point of equilibrium, because at each point the income and planned expenditure was equal. Now, if this is my C plus I plus G curve, I get the equilibrium at the point of intersection of the C plus I plus G line with the 45-degree line, and let that be at point A, and it correspond to point Y1. Now, the thinking before Keynes was Y1, because it is a point of equilibrium, or it corresponds to the equilibrium income, it must also be representing a full employment scenario. Now, there is nothing which guarantees that the economy is operating at full employment at Y1. Now, suppose Y1 corresponds to, say, 120 lakh crores of GDP, and at Y1 level we are finding the unemployment rate is 9%. Okay, the unemployment rate is 9% at Y1 level of GDP, which is 120 lakh crores. Okay, 20 lakh crores. Now, what we are saying is, suppose the full employment level of output is Y2, and Y2 corresponds to a unemployment rate of 5%, which is the natural rate of unemployment. And we know that the natural rate of unemployment is nothing but another way to represent the full employment, and this requires 150 lakh crores of output. As we know, to produce more output, we need to employ more factors of production. And suppose we know that at 100, if output of 150 lakh crores worth would be produced, that will require factors of production to such an extent that unemployment rate will come down to 5%, and that corresponds to my natural rate of unemployment. So as a policymaker, my objective is met if output or the GDP moves up from 120 lakh crores to 150 lakh crores. Okay, so how do I get this increase? Now, we know that in the C plus I plus G diagram, G was an exogenous component, G was G bar. Now, suppose G bar, suppose if I can ensure that the C plus I plus G curve intersects the 45-degree line instead of point A at point B, then my job is done. Now, how do I move from the C plus I plus G bar to this new curve? This I can achieve if I increase G from G bar to G1 bar. That means it will be C plus I plus G1 bar. So what we are saying is this distance, this curve should shift by the amount del G, and del G is nothing but G1 bar minus G bar. Now, if government spending increases so that the new aggregate expenditure line intersects the 45-degree line at a point which corresponds to the Y2 level of income, then I can say that my equilibrium point has shifted from point A to B, which will give me an output that would correspond to the full employment level of output. One question arises: how much government spending should increase? Please note that this graph is not uh, using the exact scales, so I really don't know whether this change in income, which we will call as del y, so I want to increase income by del y through increasing government expenditure by del G. Now the question arises, should del G be equal to del Y? Should del G be greater than del Y? Or can del G be less than del Y to achieve this increased output? Okay, so this is what we are interested to know. Okay, and how can I get an idea as to whether how much government expenditure would be adequate to take me from Y1 to Y2? This you'd be able to appreciate if I present the expressions for C, I and G. We know that C is equal to C0 plus BY, which is my consumption function. I is equal to I0 minus, say, FR. F is the responsiveness of investment to interest rate. And we have said that G is equal to Z bar. It can take the value of G bar or G1 bar or G2 bar depending on what is the level of government spending. Now, suppose if I say that initially income level was Y1 and at y1, what brought about this y1 level of income, or y1 level of income or GDP was consistent with a consumption of C0 plus BY1 plus I0 minus FR plus say G bar. Okay, or for notational convenience I am putting initially it was G is equal to Z0. So if you see, these are all constants. C0 is a constant, I0 is a constant, and G again is a constant. If I okay, this is my, I label it as equation 1. Now suppose government spending increases from G0 to G1, which will give rise to a new GDP level, because G is a part of the C plus I plus G. So I will get, say, corresponding to G1, I am getting a income level, say, of Y2. So what I get, C0, because these are constants which doesn't change. Then I have I0 minus FR plus now G1 bar, and this is my equation 2. If I subtract equation 1 from 2, what I will get? I will get y2 minus y1 equal to c0 plus by2. I'm putting the entire expression so that we will see how the term would be, minus c0 minus by1 minus I0 plus FR minus Z0 bar. Now we can see the expression now. C0 cancels, I0 cancels, and FR cancels. So what I get, del Y is equal to B Y2 minus Y1 plus, or rather I get plus Z1 bar minus Z0 bar. This is nothing but del Y is equal to B del Y plus del G, okay, which will give me del Y into 1 minus B is equal to del G, which in other words will give me del Y by del G is equal to 1 upon 1 minus B. So how much of change in government spending I need to bring about a particular change in Y is given by the expression del Y by del G. So what I am getting, del Y by del G is equal to 1 upon 1 minus B. Now B is what? B we know is the marginal propensity to consume, which tells how much of consumption changes when income changes at the margin by 1 unit. Now if B is 0.6, we are saying if income increases by 100 rupees, consumption will increase by 60 rupees. So B has a value of between 0 to 1, because del C can be at best equal to del Y. I will use all my increase in income in consumption, so then that will be 1. If I don't use any of the increased income on consumption, B will be 0. And this del Y upon del G is known by a specific name. It is called the multiplier. Okay, multiplier, and the multiplier value is 1 upon 1 minus B. So if government wants to increase GDP by a specific amount, how much of change in government spending it needs to undertake will be given by the will be guided by the marginal propensity to consume. We had started with the proposition that I need to increase del y from 120 lakh crores to 150 lakh crores, which was 30 lakh crores. Okay, and suppose b is zero point 0.6, then del g will be equal to how much? 30 by del g is equal to 1 by 1 minus zero point 0.6, which is 1 by zero point 0.4 is equal to 2.5. Okay, so then del g will be equal to 30 by 2.5, which will be how much? It will be 12. That means 12 lakh crores. So what we are saying, because the multiplier value is 2.5, I need to undertake spending of only 12 lakh crores to get an increase in del y by 30 lakh crores. Okay, and so as you can see, the government spending uh, has been quite effective in increasing the GDP from one level to another, and the effectiveness of government spending is contingent upon the value of B. Now, if we consider a scenario where government wants to spend, say, 20 lakh crores of additional spending, and it wants to maintain its budget deficit. Suppose the government doesn't want to incur a deficit. Now, what it would do, we are saying that government is thinking of spending 20 lakh crores, and it also wants to tax 20 lakh crores, so that it doesn't incur a deficit on account of this additional spending. Then what will be the impact on del y? Should then del y be 0 or any other number? That we can appreciate if I need to find out. I can compute the impact on del y if I compute the tax multiplier. What we have done here, the multiplier that we discussed, this is the spending multiplier. Okay, this is the spending multiplier. Now I want to compute the tax multiplier, and to compute the tax multiplier we have to bring taxes into our analysis. So what was my y? Y was equal to C0 plus B y. Instead of y, now I will use disposable income, so that I can bring taxes into my analysis. So this will be C0 plus B y minus T, and we are considering a scenario of lump sum tax. And okay, so that means government is imposing a particular um, amount of tax independent of the level of income. Okay, it's a lump sum tax. Now I have introduced taxes into my analysis. So this was what this was y, the C part. This was the C part. C is equal to C0 plus BYD. Then I have I part, I0 minus F into R plus say G0. Okay, and when I'm putting a 0, these are all constants. So, and suppose this corresponded to a income level of Y0. So I can get y0 minus t, okay, plus I0 minus f into r plus g0. Now if and suppose the tax that was imposed was t0, okay, in the first scenario, suppose this was my scenario 1, and in the second scenario what we are saying, government increases the lump sum tax from T0 to T1, and that will give rise to a new GDP level which is Y1. So Y1 is C0 plus B, Y1 minus T1 plus I0 minus F into R plus say G0. Okay, government spending is not changing, but now taxes are changing. Now if I subtract 1 from 2, what I will get? I will get y1 minus y0 is equal to c0 will cancel. I will get b y1 minus y0, then I will get minus b t1 minus t0. If you see here, this is the second equation, by1 minus bt1, then this is minus of minus bt0, which is plus bt0, and other things are cancelling. So this other words gives me del y is equal to b del y minus b del t. Del t is nothing but t1 minus t0. So what I get, del y into 1 minus b is equal to minus b del t, which other words leads to del y by del t is equal to minus b upon 1 minus b. So this del y by del t is nothing but my tax multiplier, okay, tax multiplier, and which is a negative number because you are not infusing spending, or you are not trying to follow a expansionary policy measure, but you are trying to suck out spending power from the economy, and which is having a negative impact on GDP, and how much of negative impact, that is given by minus b upon 1 minus b. Now I started with if government spending increases by 20 lakh crores, government taxes also increase by 20 lakh crores, what will be the impact on del y? And I knew that my spending multiplier, when I am taking up government spending, my spending multiplier is given by del y by del g, and when I am imposing taxes, my tax multiplier is given by del y by del t. So del y, the net impact will be how much? That will depend on the spending multiplier as well as the tax multiplier. So what I will get, del y by del g plus del y by del t, okay, and what I am getting, I will be getting 1 upon 1 minus b, which was the value of del y plus del y upon del g, and del y by del t is minus b upon 1 minus b, which gives me 1 minus b upon 1 minus b is equal to 1. So del y will be what? Because del g and del t are the same, I am getting a change in del y which is equal to 1. Here this will be either I can put del g or del t, they are the same thing because they are 20 lakhs here. So what I got is, so what this implies is del y is equal to del g equal to say del t, and this del y upon del g or del y upon del t is equal to 1. This is known by a very uh, particular name. It is called the balanced budget multiplier, and the balanced budget multiplier value is 1. What it tells is that even if government tries to increase spending by 20 lakh crores by imposing taxes of 20 lakh crores, the net impact on del Y will not be 0, but it will still be 20 lakh crores. Okay, and why this is because the balanced budget multiplier value is 1, which we got as what which we got from the del y upon del g and del y upon del t. When added, we got 1, so that gives us the expression del y is equal to del g is equal to del t. This is a very important theorem in economics. Okay, this is known as the balanced budget theorem.